So just basically, when we talk about analytical geometry, there's a couple of basic tools that we need, and I want to go over those before we get started. The one is you need to be aware of something called the Cartesian plane, and all that is basically two number lines that are at 90 degrees to each other, and we call the horizontal line the x-axis and the vertical line the y-axis, or sometimes we call it the vertical and the horizontal. And analytical geometry is really geometry, but with an algebraic feeling. And essentially, the geometry gets done on this Cartesian plane, and the Cartesian plane is filled with things called coordinates. And so, for example, we might say that is point A, and we might say the coordinate is 1, 2, because if you go 1 across on the x-axis and you go 2 up on the y-axis, you get to the point 1, 2. And so you need to be familiar with things like when I say quadrant number 1, this is quadrant number 2, quadrant 3, quadrant 4, and you be comfortable plotting points in the various quadrants. So if I said to you, okay, what quadrant is the point -3, 4 in? I'd like everybody to answer in the chat. What quadrant, you can say, is it Q1 or is it Q2? Which quadrant is the point -3, 4 in? Just want to see that we're all comfortable with the Cartesian plane. Okay, so I see things coming through. So quadrant number 2, yes, because -3 across, so let's go there, and 4 up gets me over here. So quadrant number 2. Okay, fantastic. So that's just to set the stage for this unit. The other thing that's really important is something called the distance formula. And what the distance formula does is it takes the Cartesian plane and it gives you a way of finding the distance between any 2 points on the Cartesian plane. So say, for example, I call that point A and that point B. The distance formula is a variation of Pythagoras. It's basically just Pythagoras being applied. And it's saying if I want the blue line, I can really just use Pythagoras. I can calculate the horizontal distance and also the vertical distance, and then between the 2 points, and then use Pythagoras. And the way it traditionally looks is you have a d for distance, you have a square root, you have 2 squared brackets, and then normally you'll have, it'll look like this, x2 minus x1 and y2 minus y1. And all these things are the differences between the coordinates of the 2 points you're dealing with. So as an example, if A was the point, it looks a bit like the point 1, 1. So let's say A is 1, 1. And if I look at this graph, 2, 3, 4, 5, 6, B looks like the point 6, 3 to me. If I count across 1, 2, 3, 4, 5, 6, 1. Okay, so let's just say this is point A, that's point B. In order to use the distance formula, if I want to find the distance between A and B, I'm going to have my 2 squared bits, and then I need to work out what basically the difference between the 2 x coordinates are. And in this case, 6 minus 1 is just going to be 5. And the distance between 3 and 1, 3 minus, that's the y, that's basically this thing over here. So that's going to be 2. And what did I say? This is going to be 5. Now you can see, using Pythagoras, you could work this up by just going 5 squared plus 2 squared and square rooting. The distance formula is just a variation of that. So we're just using that formula. And so the distance would be, in this case, 5 squared is 25, 2 squared is 4, so square root 29. And if you look on your calculator, that will give you 5 point something. So I want you to give me, if you've used the distance formula before, give me a thumbs up. If you've never used it, give me a thumbs down, because today's lesson, it'll go different ways depending on how comfortable students are with these things. So again, if you've never seen the distance formula, thumbs down. If you have seen the distance formula, thumbs up. Okay, so for students who haven't seen it, don't worry, I'm not going to go too quickly, but I am going to assume that we have some basic knowledge of the distance formula.
Mr. S,
Yeah.
I've got Lee asking, does it have a unit?
Does it have a unit? Okay, so whenever we measure distance, we do have units generally, but because we're on, there's no centimeters or millimeters here. So generally we would, if you really want to be careful, we just add like 5.6 units, but there's no specific unit of distance because we're just on the Cartesian plane. All right, and what is the purpose of the distance formula? Well, it just measures distance between any 2 points on the Cartesian plane. Now, another thing that we need to know is something called the midpoint formula. And what the midpoint formula does is it measures where the middle is between 2 points. So if I go back to what I was doing before, if I look at A and B, if you imagine a point C halfway between here, let's call it C, there is a formula that we can use, and I think the majority of you will have seen this, but I'll check in a moment. And the way the formula works is if you want the midpoint, I'll just say xm, ym, of 2 points, all you need to do is add the 2 coordinates. So you add x1 and x2, divide by 2, and you add y1 and y2 and divide it by 2. So in the example above, we said that the first x coordinate was 1, and in the second point, it was 6. So we add 1 plus 6, and we divide that by 2. And then the y coordinate, we had a 1 there and a 3 there. And so to find the midpoint, we add the y coordinates, and we divide by 2. And so according to my maths, we get 7 over 2 or 3.5, and 4 over 2 is 2. So the point C has those coordinates. And we will use this thing called the midpoint formula quite a lot today. But again, I want to just check. If you've seen the midpoint formula before, give a thumbs up. If you've never seen it, give a thumbs down. For this topic, these are like what I call the tools that you use. And so you need to make sure you know what tool does what before you get going with anything. Okay, so more students have seen the distance formula than the midpoint. Don't worry if it's the first time you've seen it. I will go over it slowly during the lesson, but just see if you can remember the basic idea. Define the midpoint between 2 points. You add the x coordinates and just divide by 2 for the first bit, and you add the 2 y coordinates, divide by 2 for the second bit. That's it. Okay, a lot of people haven't seen the midpoint, so I'll bear that in mind today. Then the last one that you need to be aware of is what's called the gradient formula. And I'm just going to use the points above that I gave you. So 1, 1 was the 1 point. And what was the other one? It was, oh, I changed my points there. Anyway, okay. 6, 3. So let's say 6, 3. Now, if you imagine the gradient between 2 points, let's just put A over here, and this one was up here. The gradient is how steep the line segment is between 2 points. And the formula that you've been learning about since grade 9 is just this formula. Okay, so the change in y over the change in x. And the way we would do this is we subtract the y's. So 3 minus 1 is 2. And then we subtract the x's. So 6 minus 1 is 5. And so we now say that the gradient of that line is 2 over 5. Basically, it's going across more than it is going up. Again, can I have a quick vote? If you've used the gradient formula before, give us a thumbs up. If you've never used it, give it a thumbs down. Okay, so that's reasonably well used. Fantastic. Okay, so I'm now going to go through a series of practice questions to see how well you know these tools, because we need to know them very well for this topic. Okay, so I think you are comfortable with, let's just do this first one first. We'll start with the Cartesian plane. And I think I have already given you this question, so let me change it to make it more exciting. In which quadrant do you find the point -3, -4? And I want you to vote in the chat to show me you have an outstanding knowledge of quadrants. So you can vote with A, B, C, or D. Okay, so -3, -4, that would be 3 across and 4 down. And so this is going to be in the third quadrant, which is quadrant, or in the question it's C. Now, I don't think there's too much trouble with that, so I'm not going to spend too much time. All right, next up, I want you to work out the distance between these 2 points. And I'm going to give you 2 minutes to do that, maybe even a minute. And all I'm going to do to help you a little bit is I will give you this basic structure to just get your brains, because I find if my students remember the structure, it makes life a lot quicker. So which of the options, A, B, C, or D? And while you work on that, I'm going to get some more water. Okay, so some answers are coming through. Let's give it a bit of time. So remember that when I did this, we basically are looking for the change in X and the change in Y between the 2 points. That was what it says X2 minus X1, Y2 minus Y1 was what was there. We just have to be careful when we go 4 minus -2, we're going to get 6 in here, and then -3 minus 5 gives us -8. So what do we have for all that? We have 36 and 64, which should give us 10, which is A. Now, I want you to look at the technique I used there, guys. So distance formula always has the same structure. It has this big square root bracket, then it has these 2 smaller brackets, and we're always working out basically the difference between X and the difference between Y. And so I want you to try and, get used to that structure. I see pretty much all the answers seem great. And so I think what I want to do is I want to try a little bit tougher question. Still using the distance formula and bringing in a little bit of something from circles, which we did in our previous, although you don't need to have done the previous units. You're given 2 points on the opposite ends of a diameter of a circle. And I want to know what is the radius of the circle. And it might even help to draw yourself a little diagram. So -3, 2 would be over here. And 12, 10 is probably up here somewhere. And they're saying that this is a diameter for a circle. And they want to know what is the radius of the circle. So over to you guys. Amaze me. What can you do? I suppose one way is you can also think of, basically they're saying there's a circle. So I think a good place to start is to find the distance. So let's do that. And what do we have? So 12, let's be careful here. 12 minus minus 3 is 15. And then 10 minus 2 is 8. But now we need to do a little something more because we're not quite done. And to be honest, I wouldn't be afraid of using your calculators when you need to. So here, 15 squared plus 8 squared gives me 289. So I need to get the square root of 289, which is 17. But I don't see 17 as an answer here. Well, actually, I do see it, but it's not the right answer. So why is 17 not the answer? Well, because you found the diameter, and what you want is you found this green thing. So you know this green thing is 17. But what you really want is the radius, which is half that. And so the answer will be 17 over 2, which is 8.5, which is C. Okay, so you really get a sense of how in this section, it's not just about knowing the tool, it's also about knowing about the shapes that can exist on the Cartesian plane. Okay, Coco, anything from your side? Anything to be aware of? Or are we all good?
No, I think we're all good. Yeah, I think this one is a bit tricky, but if you understand it, you'll get it quite easy. Yeah.
Okay, last one on the distance formula. I want to know, I'm giving you now a parallelogram. Okay, a parallelogram that is on the Cartesian plane. I want you to find for me the perimeter of the parallelogram. And just to remind you what perimeter means, it means the distance around the outside of the shape. So what is, now this is going to take a bit of time. So I want you to think about, you need to find AB, you need to find BC, you need to find CD, and you need to find DA. So over to you guys. Make sure if you get this right, I think you've mastered the distance formula, but you'll need some time. So Bradley, the perimeter of a parallelogram is just the distance around the outside. And so all you need to do is find the distance between each of the points. So what I did was I started by writing out each length that I need to know. And so what you need to then think about is, how do I find the distance between A and B? And obviously you're going to use this thing called the distance formula. And whenever we use the distance formula, we always start with this same structure. So today we're just making sure we know how to use the tool called the distance formula. And I want to suggest that it's a bit predictable, and it always starts off, at least, it always has this structure. And so we just need to get some practice. I'll give you a bit more time. I suppose what I should do also is, why don't I write down each point? So on the drawing, here is point A. Point B. And one of the things in the section is you have to get comfortable looking at points on the Cartesian plane and reading them off. So 4, 5. C is 9, 7. And what's D? D is 6, 3. So now that you've got the 4 points, this is a bit of a maybe it was a little bit long for today, but I really want to make sure we practice this because this is like 4 questions in one. So let's try and get AB first. Let's get AB first if you're feeling a bit overwhelmed. So for AB, I'm just going to go 4 minus 1 is 3. So I've just said x minus x, and then the y bit is going to be 5 minus 1, which is 4. So what do we have? We have 3 squared plus 4 squared. That's going to be 9 plus 16. I put that in my calculator, and I get 25. So the square root. So the good news is AB is the distance 5. That's what I've worked out. So that distance over there is 5. Now I need to still work out these next 3. And once I've got them all, I'll add them together. So what about BC? So I think what I do is I just connect them, like, let me just use a different color, but so 9 minus 4 is going to be 5, and 7 minus 5, and then I can actually see that this has taken a bit longer than I expected, but I'll show you how I would speed up. So CD is going to be 9 minus 6 is 3. So I've just subtracted those 2. Well, I suppose I should be the other way around. Okay. As long as I'm consistent, it's fine. So 9 minus 6 is 3. 7 minus 3 is 4. So you may ask yourself, okay, why am I... It doesn't matter where you start as long as you're consistent. So 9 minus 6 is 3. 7 minus 3 is 4. And so I've got that. I'll work out later. And then what's the last one? The last one is DA. Now, what is DA going to be? I'm just going to write my A's below here. And so I go 6 minus 1 is 5. And then I go 3 minus 1 is 2. Okay, so this is going to be the square root of 29. This is also going to be 5. And then this is going to be the square root of 29. Now, I probably have gone a little bit fast for a lot of you, but it's basically just practicing the distance formula. And the main thing I want to point out is that it always has the same structure. And then ultimately what you do is you subtract the x values and you subtract the y values. And as long as if you write them beneath each other, it actually makes it a bit simpler. And you must be consistent. So you can't start at C and then start with X and subtract there and then go the other direction. You must always be, if you start somewhere with the X, you start there with the Y. Okay, so what's the final answer going to be? It's basically going to be 5 plus square root 29 plus 5 plus square root 29, which are these, which is going to be the following. Okay, so square root. So Mr. I get,
I think Luyanda has a question.
Okay, the answer is C. So just so we know, the answer is C, which I think, Luyanda, go ahead and ask your question. Luyanda, go ahead.
Oh, well, he's put his hand down, so I'm not sure if he still has a question.
Okay, no problem. Okay, I just want to get a feel for the room. If you feel like you understand the distance formula, give a thumbs up. If you feel like you're a bit overwhelmed, thumbs down. Now, I did put a lot into that last question, maybe a bit much, but I hope that on the whole, the structure of what I'm doing is clear. Okay. All right, fantastic, because distance formula is an important one. All right, I think we're going to take a little break before we move on to the second part of the lesson. And so all I want you to do is I want you to, we're going to, instead of having a physical brain break today, we're going to do a little puzzle. And so I want you to stand up for a second anyway. So just stand up from your table. But we're just going to take 2 minutes to do something completely different, unrelated to what we're doing now, and give our brains a break. And so I'm going to give you a riddle. And so while you're standing and stretching, I'm going to stand and stretch as well. I don't know if you can see me anymore, but and I want you to just think, can you solve this riddle? And if you can solve the riddle, put your answer in the chat. I see people have raised their hand. I will take questions while we're working on the riddle. DeAndre, I see you've raised your hand. Do you want to ask a question?
Yes, sir. Sir,
Yeah.
with calculating the distance for DA, why did you start with 1 minus 6? Do we not start with point D's coordinates being x1 and y1 because it's DA?
Okay, so 6311, that's the one we're talking about while everyone's working on. So 6311.
Yes, sir.
And that was B and that was A. So it actually doesn't make a difference as long as you're consistent. So what are you wanting to do? Are you wanting to go 1 minus 6?
Yes, sir.
Perfect, not a problem. But if you do that, you need to make sure that it's 1 minus 3 in the other bracket. So as long as because you'll see that what you get here is you're going to get the same answer in the end, because when you square and this, you get that in the end. So in the end, it doesn't make a difference as long as you are consistent.
Okay, sir. Thank you.
Perfect. Okay, now I see some answers are coming in for the brain break puzzle question. We're trying something a bit different today. And I think a lot of you know, or it seems like you can see that the blue suite should be 3. So I see that. And so can you solve the final answer? What do we have here? So the red suites, let me be careful here. Okay, so this is going to be, this has to be 3. 3 times 3 times 3 is 27. Then if this is 3 and that's 3, 3 times 3 is 9. Oh, wait, sorry, 3 plus 3 is 9. No, 6, sorry. So this is 2, so that must be 1 and 1. Coco, do you agree with me so far?
I'm a little confused. That first line also kind of threw me off.
Yeah, so if you look at these, so the goal is to get these ones. I'm just working through the problem. And so far the answer, some people have said 10, some people have said 12. And so I'm just thinking this through. So I know that the blue suite has to be 3. If I got 2 of them, I've got 6, which means 6 times 2 is 12. So the red suite, one red suite must be equal to 1. Now, if I go to the very top, if I make this a 1, then the pink suite must be 4 and 4. Okay, so then I feel like I know kind of what I'm doing, because the pink suite is 4. So if I go to the very bottom now, I have 1 plus 4 times 3, which gives me 13. So did anybody get 13? Did anybody agree with me? Let's have a look. Andile, Luyanda, they agreed with me. And a couple of you agreed with me. Okay, so I am like 99% sure I got this right. And so that was just something a little different to kind of get our puzzle brains working today. Are there any questions or comments about that? Okay, BODMAS. Yeah, BODMAS. So BODMAS says that I have to do this bit first before I do that bit. The other thing that almost caught me was this. I feel like that was tricky because you had to say, okay, you add the 2 blue sweets, which is 6. You then get 2, but there's 2 of them, so that there must be 1. Okay, so that was just something different. I hope that you enjoyed that. If you enjoyed it, give us a thumbs up. If you didn't enjoy it, give it a thumbs down. I'd love to see how you felt about a different brain break. Okay. Yeah, we'll try and mix it up. I'll try and mix it up each week. So I'm glad you enjoyed that. Okay, so what have we done today so far? We did this monster distance formula question. I'm not going to go any further into the distance formula right now. I want to practice in the second half of the lesson the midpoint formula and the gradient formula. So let's start with this question. What is the midpoint of the straight line segment between the points -2, 5 and 6, -1? I want you to try and answer that and put that in the chat. So if we think of this being maybe like point A and this being point B, -2, 5, so maybe it's somewhere up here, and 6 -1, maybe it's down here. You don't have to do the drawing, but I'm trying to find where is halfway between these 2 points. Can you remember what we did? So the midpoint formula, because I know a lot of you hadn't seen it, in order to find the midpoint, we add the 2 x coordinates. So we go -2 plus 6. Let's make sure I know where I'm. So there's the first. So -2 plus 6. And I divide by 2. And then I do the same thing for the y coordinates. So I go 5. Oh, that looks like green. Let me go back. So there's the y, there's the y. And so we go 5 plus -1 over 2. And so according to my maths, the midpoint should have a 2 to start with. And then we should have a, so 5 is 4, we should have another 2. Is there a 2, 2? There is a 2, 2. So in order to find the midpoint, you should have got 2, 2. And I think for the most part, we are good there. Oh, well, fantastic. Let's take it up a notch with a few more fractions. So what is the midpoint of this one? Okay, and this is a little bit trickier because the numbers are a bit more negative and a bit more, interesting. So over to you guys. Show me you've got it. Coco, are there any students who want to ask questions while we're doing this? Or have been holding a question?
None at the moment, so I think they're all kind of getting it.
Okay.
It's looking good. Yeah.
Fantastic. I'm enjoying drawing with my pretty colors, so I hope the students are having as much fun. My camera was still a bit out of place.
Mr. S.
Yeah.
Can I just point something out? Because I realized I used to do this as a student myself.
Yes, please do.
When I was in school, I used to get the midpoint and the distance formula kind of switched around because I couldn't remember that the distance actually gives me a length and the midpoint actually gives me brand new X and Y coordinates. Yeah, so I needed to learn or remember that the difference between the two is one is just going to give me a distance and the other is going to give me two brand new points. So another point on the Cartesian plane. And that was something I used to get mixed up quite a lot.
Totally. That's actually, and I think especially in this first lesson is all about getting your toolkit ready. And it's really important that, you associate the distance formula with a distance, like a length, whereas the midpoint literally gives you another point. So, in the previous question when I was drawing okay, I won't draw it there, but, in this, what Coco is saying is like, these are 2 points, minus 2, 9, let's say up here, and 3, like down here. When you use the midpoint formula, you don't get out the distance, you get out literally another point halfway between those 2 points. And so it's important your brain gets that. I can totally see why that would. Thanks for that, Coco. I'm sure that you are not the only person who's had that before. Okay, I see some answers coming in. So I'm going to start working it out myself. And I get 9 plus. So what used to catch me a little bit was this plus minus business. So you have to remember that, and especially if you're stressed or if you're in a rush, plus minus is the same as a minus. So, it's very easy in the first bit when we go, minus 2 plus 3, that's a piece of cake. There's your minus 2, there's your 3. But the y coordinates where you go 9 plus minus 2, students can make some silly mistakes. So let's just see if we can avoid that. So minus 2 plus 3 gives me 1, and the 2 stays there. 9 plus minus 2 actually gives me 7 over 2. Now, I don't see any 7 over 2s, but what I do know is 7 over 2 is the same as 3.5. And oh, sorry, what happened there? And so my answer would be not B, but C. That would be my answer for the midpoint, which I think seems to be the majority of students. Okay. Any questions or comments? Again, if you're getting this wrong for now, don't stress. The whole point of this is we're trying to find where there are some areas where you need to brush up and you can go back and practice some more. But the hope is that at least you get a feel for it in this hour. Okay. Oh, sorry. So I'm introducing what they like in this section is they love to give you diagrams. And so it's important that from the very beginning, I introduce diagrams, because later in this topic, I'm going to be giving you shapes and we talk more and more about shapes. But anyway, for now, I want you to find me the midpoint of AB, but AB is not just, I'm not giving you A and B, you have to go hunt for it in the drawing. So let the hunting begin and then show me what answer you get. Ms. Ole, yeah, we will get to questions like that. Maybe I'll even sneak one in tonight. But for now, I want to make sure everybody is really comfortable with the midpoint formula and the distance formula. But yeah, trust me, I will mix it up. It's just, yeah. Okay, so sometimes the notation we use is like we use midpoint AB, or even sometimes you see people write, and then the AB is like a little subscript. So what do we have? Minus 5 plus 7 over 2. So that's this bit. And then we have this. So we have 2 plus 7 over 2. And as long as I don't make a silly mistake with my minuses and my pluses, I should get 2 over 2 and 9 over 2. But I don't see that yet, which means I may need to simplify stuff. And I think I can simplify that. So I get 1. And then the next one would be 4.5. Is there an answer that matches? I think there is. Is it C again? It is C. Okay, awesome. So good news is midpoint formula, obviously what happens later in the section is I might now say, okay, you found what this midpoint is. Now you have to use that in another calculation, which like find the equation of the straight line and stuff. So the questions tend to be interrelated, but you have to, at a minimum, get the basic tools, the basic formulas right. Okay, this is a little bit of a sneaky one, but I like it, so I'm going to keep it in. So what are the coordinates of the point that divides AB in the ratio 1:3? I will give you a tip in a little bit of time, but I want you to try and fly solo because you will love it if you get the answer and I say nothing. So think about it. I know, Coco, I believe in my students. I'm going to push them like a good personal trainer. Climb the mountain. So we're dealing with A, B, which is here and here, but the question is slightly different. We're trying to find a point that divides AB in the ratio 1:3.
So correct me if I'm wrong. So yeah, we'll be closer to A than we would to B, correct?
Yeah, if the answer doesn't match, so I'll say this. It's not a bad idea to start by finding the midpoint.
Yeah.
If you find the midpoint, that's a good idea. Oh, why somebody's... Sorry, guys. I'm going to turn it off. Let me grab my phone. Mute. There we go. Sorry, guys. Apologies about that. You can tell it's live. So if you want to find the midpoint, what I want to suggest is that I agree that it could basically, it could be over here, the point you're looking for. I think that's what it's asking for. But even if that's not, you could just test by seeing which option is here. So let's first start by finding the midpoint of AB. And I think that would be a 7 plus minus 1/2. So let's just make sure I haven't made any silly mistakes. So this is 0/2, and this is 6/2, which really gives me the point 0.3. Now, this is not the answer. I know it's one of the options, but that's not what the question is asking. But let's just first write this point here, 0.3. Okay, so if we divide something in the ratio 1:3, do you agree that if I divide this and get in half again, so if I find where the midpoint is between these two, that is then going to mean that because these are halves, this piece over here is 1, and if that piece is 1 and that piece is 1, I'll put a little midpoint there, and that piece is 1, that's how I get the ratio 3:1. So I want to suggest that you try and find the midpoint of A and 0.3. Okay, so I see some answers are already, I see some of you have said A. The answer is not A, but I want you to try again. So now that you've got 0.3, how do I get the midpoint of these two? And then I want you to try and answer the question again. So -6 plus 0/2, then 7 plus 3/2, which gives me -3. Is there a -3.5 as a possibility? I think there is. So it's down here. Okay, so I just wanted to show you how teachers, not say teachers are going to make it difficult on purpose, but when you understand what the midpoint is, if you find the midpoint and you find it again, can you see how it splits? You know, essentially, the 1:3 way is a fancy way of saying find the midpoint and then find it again. Okay, but that is a little bit harder for lesson 1. Give me a thumbs up if you feel like you sort of get the idea here. Give me a thumbs down if you feel like, okay, that was a tricky one. I have no clue what's going on. Okay, so it's about half and half. The main thing I wanted to show you is that once you master the midpoint, in later lessons, we also need to know how to interpret questions using the midpoint, but we're not there yet. Today is warm-up round. Okay, so don't feel too bad if you know, I'm just chucking it in there to get you going. Okay, let's do some gradient formula. Let's finish with that. I want you to tell me which of the 3 options or 4 options for gradient. So first of all, if you go back to grade 9, gradients that go like this are positive. Also, lines that go like this have gradients that are positive. And if a line goes like that, it's negative. So I think we can already cross out those 2 because it looks like a positive line to me. But which of those 2 is it going to be? So if you remember grade 9, you can just count the blocks. Or grade 10 maybe as well. So that's 4, that's 2. And the formula for gradient is the change in y with the change in x, or it's that. Okay, so because the formula for gradient is change in y on top, the change in y, or the change in vertical, is this one here. So that one has to be on top. So when the gradient, it's going to be 2, and then on the bottom, it's going to be 4. But there's no 2/4 here, but 2/4 is the same as a half. And so the answer will be question C. Okay, let's do another one. What's the gradient of this line segment? So the gradient here is going to be negative, but remember which one has to be on top. So this is a sneaky one. Okay, the 5 must be on top and the bottom must be 3, but I don't see any 5/3s here, but this is an improper fraction. So this is -1 and 2/3. Is there a -1 and 2/3? There's A. Cool. What about this one? Sorry, this should be a 0. So I got mixed up. What's the gradient of this line segment? Okay, some of you are saying undefined, some of you are saying B, 0. Okay, so if you think about the formula change in y over change in x, So, well, I mean, that's one way of doing it. If you look at this, there's no change in y, right? It doesn't go up at all. So this is 0. So there is change in x, but there's no change in y. But 0 divided by anything is 0. And so the answer is going to be B. The other way of thinking about this is it's flat. If it's completely flat, it has no gradient. It's 0. However, those of you who answered D, you're probably thinking of this type of line. If the line is straight up, a vertical line, then we say the gradient is undefined. Okay, but if it's completely horizontal, we say the gradient is 0. And that's just something to bear in mind. But the answer here would be B. Okay, what is, in fact, I'm going to make it a little bit easier for you. I'm going to give you a point A, and I'm going to give you a point B. So this is going to be the point 0, 2, and this is going to be the point 1, 5. I want you to work out the gradient of that line for me. So I've given you the point 1, 5, which is on the line, and then the point 0, 2, which is also called the y-intercept, in case you are reaching back into your memory. What is the answer to this question if you have to find the gradient? And I'm feeling so friendly today, I'll even help you with the formula, because it is on the formula sheet. So some answers are coming through. The thing that, Coco, I find students mess up with this one is sometimes they put the X on top, not the Y. That's that happens so much. Yeah. So what I'm going to do here is I'm going to highlight the Y's first, and I'm going to go 5 minus 2, because the Y's are on top, and then I'm going to do the X's next, which is 1 minus 0.
Yeah, you know what I also used to do, Mr. S?
Yeah.
I would start at 1 and 5 for the Y's, and then for the X's, I'll start at 0 and 2. And I'm not supposed to do that because the answer kind of gets mixed up somewhere.
Yeah. My experience is you start by just focusing on the Y's because they go to the top, and we're so used to going on top. Like it's just, natural type of thing. Okay, so we get 3 is the answer, and that would be D. Okay, so watch out. And in fact, I see some students have chosen C, which is exactly that mistake, right? So it's where you flip, you put the Y on, it's really important. If I make one thing clear today, it's the change in Y over the change in X. And so you should be subtracting Y coordinates on top and X coordinates on the bottom. And you can see this in this graph too. If you manually count it out, if you go across by 1 and you go up by 3, which is basically saying the gradient is 3. 1 across, 3 up. And so that's why I know the answer had to be 3. Okay, let's squeeze in one more question, if there's time. Actually, no, I don't want that one. Let's get this one. So what is the gradient of this line? And I will give you a point. The point over here is the point A, and that is the point 0, 1. And the point B is down here, and it is going to be 1, 2, 3, 4. So that's going to be 1 minus 4. And I'm just doing that because I actually want you to get some experience working with the points tonight, as well as the drawing. So what is the gradient of AB? And then show me the answer in the chat. And then while you get that, I'm going to release a poll that when you finished with this question, you can answer. And this is just to help us. We're thinking about offering some exam classes, but we want to know what topics you've covered so far this year in preparation for your exams. And so it's just helpful for us to plan if we know roughly what students have done so far this year. Okay. But first the question, then the poll. Oh, there's a nice double negative in there to sneaky. So that's my final answer here. So we get 5 minus 1. So my answer for the gradient of that line is -5. Okay, so today has been all about just getting the basic tools in your toolbox for the rest of the section. And in the next lesson, what we're going to do is we're going to bring these tools that you learned, these three, distance formula, midpoint formula, and gradient, and we're going to mix them together with the straight line. But in order for that, for all our energy to be on straight lines, we want to have mastered these basics. And so if you're still feeling unsure about these basics, I would encourage you to practice a little bit before Wednesday. You will get some more practice on Wednesday, but you want to get these basic tools sorted. Okay, Coco, is there anything from you? I will take some questions from students now, but anything important from you that you've spotted?
Not for now. No, thanks, Mr. S. Just Wednesday's quiz day. Yeah.
Wednesday's quiz day, totally. Wednesday is quiz day, and so that'll be good. Okay, I see there is some raised hand. I'll do my best to answer before we run off. Who's first?
I think Kuskani is first. I hope I'm saying that correctly.
Go ahead, Kuskani.
It's Koziani. The other question before this one, you did it the opposite way, like the way you solved it. I thought it was supposed to be y2 first, but you did y1 first. And that confused me.
Okay, so the good news is I know exactly what you mean. It's not a problem. If I start with B or I start with A, it doesn't make a difference as long as I'm consistent. So if I show you this, what I did, I think, was I went 5 minus 2 over 1 minus 0. Notice how I started at the top both times, and I got the answer of 3. But if I started with B, I would have gone 2 minus 5, and then I would have gone 0 minus 1. But in that case, I have minus 3 over minus 1, which is still going to give me 3. So the good news is it doesn't matter. Choose whichever one is useful to you. But once you make a choice to start with something, stay with it. You can't mix and match. So I hope that helps a little bit. Okay, who else? Yep.
Bushali, do you have a question?
Sir,
Yeah.
is trigonometric functions in term 2 or term 3?
So it doesn't, different schools do it differently. So it depends, to be honest. We did it in term 1 or in the first half of the year, but different schools do it differently. I think the majority of students have done it in the first half of the year, but there's not really a right way to do it, to be honest.
Okay, thank you, sir.
Cool. Okay, I'll do one more question. Otherwise, if you,
Mbali, do you have a question?
Mbali, do you want to go ahead? Anyone else?
She's not unmuting.
Okay.
I don't know what's happened.
It's fine. Okay, everyone, I think we've done well today. I think it's time.
Sorry, Mr. S, she's asking, are you going to teach us the rise and the run?
We can go over that a little bit. Why don't we do that now, just quickly, before I go? Okay, so if you look at the graph that's here now, if you want to find the gradient of this line, there's two ways of doing it. The one is to manually count it. The other one is to use the formula. Now, when I say the rise over the run, all we're talking about is, let's talk about this point and this point. Because you always need to focus on 2 points to do something. We call this bit where we go across, we call that the run. And the bit where we go up here is called the rise. If we count the blocks, 1, 2, 3, 4, the run is 4 and the rise is 1. And so using the gradient formula, we would say the gradient, because it's going up and to the right, it's a positive gradient. And then rise is 1 and run is 4. So it's a quarter, which would be this answer here. Now, if I'd done it with the formula, I would have got the same answer. I just would have used the point. This point over here is the point 0, 1. And the point here is 1, 2, 4 across, 2 up. So I could have used these 2 points in this formula, but I would have got the same answer. So that's what I mean. Rise of a run to me just means to manually count the blocks on a picture. So I don't know if that helps you a little bit. In grade 11, we start to use this formula a bit more. And so we need to practice this, and we'll continue practicing the next lesson. Okay, we really must finish now. Thank you so much, Coco, and to everyone. I will see you all on Wednesday.
All right. Bye, everyone.
Ciao, ciao.